Hello, everyone. In this lesson, we will introduce the knowledge of reactors. We will mainly cover five aspects, which are the classification and functions of reactors: shunt reactors, current limiting reactors, series reactors, and usage knowledge of reactors. First, we will introduce the classification and functions of reactors. First, by the number of phases, they can be divided into single-phase and three-phase reactors. Second, by the type of cooling device, they can be divided into dry-type reactors and oil-immersed reactors. Third, by structural characteristics, they can be divided into air core and iron core reactors. Fourth, by installation site, they can be divided into indoor and outdoor reactors. Fifth, by purpose, there are shunt reactors, usually connected at the end of extra high voltage transmission lines, and flow to provide reactive power compensation. Current limiting reactors connected in series in power circuit to limit the value of short circuit current. Filter reactors connected in series or parallel with capacitors in filters to limit higher harmonics. Arc suppression reactors to compensate the capacitive current flowing through the neutral point and eliminate overvoltage communication reactors used to block carrier signals to complete communication functions. Furnace reactors used to limit the short circuit current of transformers. Starting reactors used to limit the starting current of motors. Next, we will introduce shunt reactors. First, model of shunt reactors. The model of shunt reactors consists of three units, corresponding to product model letter, rated capacity in kilowatt, and voltage level in kilovolt. Second, functions of shunt reactors. As shown in the figure, A shows the wiring of medium voltage shunt reactors. B shows the wiring of extra high voltage shunt reactors. Medium voltage shunt reactors are generally connected in parallel at large power plants to absorb the capacitive reactive power of cable lines and adjust operating voltage. Second, extra high voltage shunt reactors are generally connected in parallel on 330 kV and above on extra high voltage lines. Their main functions are: first, reducing power frequency over voltage; second, reducing operating over voltage; third, avoiding self-excitation resonance phenomena when the generator is connected with a long line. Fourth, facilitating single-phase auto-reclosure. Third, structure of shunt reactors. First, air core reactors have only windings, no iron core. Second, iron core reactors. The core columns of iron core shunt reactors are made of core cake and air gap pad. The oil tank is of bare jar structure for easy maintenance and inspection by users. Third, dry-type semi-core reactors. Dry-type semi-core reactors have core columns made of high permeability material inserted into the windings. The windings use small section round wires wound in parallel. Next, we will introduce current limiting reactors. First, functions of current limiting reactors. The purpose of installing current limiting reactors is to limit short circuit current, to economically and reasonably select electrical equipment. Reactors can be divided into three categories based on installation location and function. First, the first category is line reactors connected in series on lines or cable feeders to allow the use of light-duty circuit breakers for outgoing lines. Second, bus reactors connected in series at the segment points of generator voltage buses or on the low voltage side of main transformers to limit short circuit current during internal or external short circuits. Third, transformer loop reactors installed in transformer loops to limit short circuit current. Second, types of current limiting reactor structures. Current limiting reactors, according to different structural forms, can be divided into concrete column type current limiting reactors and dry type air core current limiting reactors. Both have ordinary reactors and split reactors. First, concrete column type current limiting reactors consist of windings, cement columns, and post insulators. Second, split reactors. Structurally, they are similar to ordinary reactors, but with a tap in the center of the windings, forming two branches. Third, dry type air core current limiting reactors. Their windings are made of multiple parallel small conductors wound in multiple strands. Third, model of current limiting reactors. The model and meaning of concrete column type current limiting reactors are as follows. The first unit indicates structural characteristics. The second unit indicates winding material. The third to fifth units indicate rated voltage in kilovolt, rated current in A, and percentage reactance. Next, we will introduce series reactors. Series reactors are connected in series with shunt capacitor compensation devices or capacitors in AC filter circuits. As shown in the figure, A shows a series reactor connected to shunt capacitors switched by a circuit breaker. B shows a series reactor connected to shunt capacitors switched by a thyristor. Their main functions: first, reducing the inrush current multiple and inrush current frequency of capacitor banks. Second, absorbing harmonics to reduce distortion. Third, limiting harmonic currents flowing into capacitor banks. Fourth, reducing internal short circuit current and limiting external short circuit current increment. Fifth, reducing the discharge value from healthy capacitor banks to faulty capacitor banks. Finally, we will introduce the usage knowledge of reactors. First, layout and installation of reactors. Line reactors are usually installed vertically. Each reactor and its insulation should be insulated from the ground. The winding directions of the middle phase reactor should be opposite to the winding direction of the upper and lower phase reactors. Bus reactors are installed horizontally or in a delta configuration. Second, operation and maintenance of reactors. During normal operation, pay attention to the joints. They should have good contact and no overheating. The reactor windings should not be deformed, and other precautions. This concludes the content of today's lesson. Thank you, everyone.